Today we're going to continue practicing the substitution method. Remember that instead of graphing to figure out what your answer is, that you can use the substitution method. We also talked about when you were graphing that you actually had three different types of solutions. One solution was when the two lines intersect and we have the coordinate where they intersect. Well, if we're doing this stuff by hand, this just means like I was able to get a number for an x and I was able to get a number for a y. A no solution will occur when we're doing our work and we get a false statement, we can say no solution, and I'll explain more later. Infinitely many solutions means when we're doing our work and we come out with a true statement, and again I'll explain that more when we get to an example. So from the other day on Tuesday, our notes, we had some steps. Step one is you always want to solve an equation for a variable. Sometimes they do this step for you, and if they do, then we get to move a little bit quicker. But if not, you want to pick a variable that has a 1 in front of it if it's possible. If it's not possible, we'll deal with that in an example. But if there's not a 1, then you would want to look for a -1. If there were neither one of those options, then you would want to find a number that line is all divisible by. Okay, and we'll come up with an example in a minute. Then we're going to substitute that expression from step 1 into the other equation, and we're going to solve for that variable. Once we have one variable, we're going to have to figure out the other variable by solving it, and we're going to do that by taking this answer and plugging it into the equation from step 1. I know it seems kind of a lot, but the more you do, the faster you'll get at these. All right, so let's take a look at our first example. It says solve by substitution. So the first thing is I want to pick an equation and I want to solve for a variable. Now remember, I want to pick a variable that has a 1 in front of it. So this x has a 1 in front of it and the y has a 1 in front of it. So I want to pick either one of those. If you choose to pick one of these, okay, you're just kind of giving yourself more work, and sometimes you might end up with fractions, and you guys are better off when you don't have to deal with fractions. So, I don't know, you can pick either one of those that you want to say, I want to get by itself. So I'm going to pick the first equation. Okay, so first equation, x plus y equals 3. And I'm going to say, you know what, let's just solve. It really doesn't matter. Let's say we want to solve for the x. Okay, so to do that, I need to then subtract the y over. That way my y's cancel, and I get the expression that the x is going to equal 3 minus the y. All right. Now my step 2 is I want to sub that into the other equation. So sub your answer into the other equation. All right, so I want to substitute into the x. So here's my x. And instead of writing an x, I'm going to sub it in with its expression. All right, so I'm going to say that I've got -4, but now instead of an x, I'm going to substitute what our x is, which is 3 minus y. Then I'm going to say minus 4y equals 12. Okay, so now I'm going to solve that, which is step 3. Okay, so we're going to clear out our parentheses by distributing. So -4 times 3 is -12. -4 times a -y is a positive 4y. Then I finish out the equation, minus 4y equals 12. So I'm going to combine like terms. So I'm going to say -12, -4y minus 4y. Those cancel out completely to 0. So I don't need to say 0y equals 12. Does -12 equal 12? No. So since that is a false statement, this is a no solution. So your final answer to me is a no solution, which means had we graphed these, they would have been parallel lines. Okay, let's try another example. So first off, again, I want to, step 1, pick one of these equations and isolate one of the variables. And again, I want to pick a variable that has a 1 in front of it if possible. So I'm not going to solve for that one. I'm not going to solve for that one. That one has a -1. This one just has a +1. So that's the one I'm going to go for. So I'm going to say, okay, I'm going to use the second equation. And I'm going to solve for the y. Okay, so to move my x over, I'm going to do the opposite of a -x. So I'm going to add x. These are unlike terms, so just leave them separated. We're going to say 5 plus x. Okay, so now step 2 is you're going to take this expression and you're going to solve it into the y on the other equation. So this is where I'm going to sub it into. All right, so looking at this other equation, it's 3x minus a 3, but instead of the y, I'm going to substitute in its expression 5 plus x, and that is equal to -15. Okay. Step 3 is start solving. Clean this up. So I have 3x. I'm going to distribute. That's going to give me -15. -3 times x is -3x. Again, I'm going to combine like terms. So instead of saying 3x minus 3x, that cancels out to 0. And I'm left with the statement that -15 equals -15. That is a true statement. And true statements mean that I'm going to have an infinitely many solutions. I'm going to shorthand that a little bit. Which means if we had graphed them, they would have been the exact same line. All right, let's look at a case where they don't give us a coefficient of 1. All right, so I need to solve for one of these variables. Okay, one option's better than the other option. So since I don't have a 1 and since I don't have a -1, I would want to ask myself, is everything in this equation divisible by a 2? Yes. Okay. Is everything in this equation divisible by a 6? No. So I don't want to pick that one. I could ask myself, if I want to use this equation, is everything divisible by a 3? No, 5's not divisible by 3, so I don't want to pick that one. And then if I wanted to solve for that variable, I would say, is everything here divided by a 5? No. So we're going to go ahead and say, you know what, everything in the first equation was divisible by the 2. So we are going to isolate the x term in the first equation. Since everything was divisible by 2. Okay, so I'm going to say 2x plus 6y equals 16. So I want to get this by itself. Let's subtract our 6y over. That way that cancels out to 0, and I'm left with 2x equals 16 minus 6y. If you wanted to write it -6y plus 16, that's fine. Inverse of multiplication is division, so I'm going to divide each term by 2. And now I have my variable isolated. I have x equals 16 divided by 2 is 8. -6y divided by 2 is -3y. So since we used the first equation, I want to substitute this expression into the x on the other equation. So I'm going to substitute it in here. All right, so for step 2, I'm going to write 3x, but our x we just found out was that 8 minus 3y. Then I'm going to say minus 5y equals negative 18. There's my substitution. And now we can start solving. Distribute. So 8 times the 3 is 24. 3 times negative 3 is negative 9y. Then we have minus 5y equals negative 18. I'm going to combine like terms. So negative 9y minus 5 more y's is negative 14y. Okay, so since nothing canceled out completely, that means we're going to get a solution. So now I'm going to subtract the subtract 24 over. I get negative 14y equals negative 42. Inverse of multiplication is division. Okay. Negative divided by a negative is a positive. 42 divided by 14 is 3. So now that I have a solution for the y, I need to figure out what the x is going to be. Okay, so I'm going to substitute this in. So I'm going to substitute this in to the y from the equation from step 1. So I'm going to put it in that spot. Okay, so I'm going to say x equals 8 minus 3y, and our y was 3. And then I'm going to keep solving that. So I'm going to get x equals 8 minus 9. So our x is negative 1. So now write your answer as the ordered pair. And go alphabetical. The x was negative 1. And your y was 3. So had we graphed these, they would have intersected at that point. All right, last example. Step 1, I want to solve one of the equations for y, and I want to solve the equation that has a 1 in front of it. None of these have a 1. That has a negative 1. So I'm going to choose to solve the first equation, and I'm going to solve it for the y. Okay, remember that's a negative 1. So we're going to get that by itself. We're going to subtract our 5x over. So I have negative 1y equals 18 minus 5x. And then I need to remember to divide everything by a negative 1. So I get y equals negative 18. Negative divided by a negative is a positive. Okay, so now I know that my y value can be replaced with a negative 18 plus 5x. So I'm going to substitute this into the other equation for its y. So I'm going to substitute into that spot. Okay. All right, so I'm going to say 10x minus 2y, and our y is negative 18 plus 5x, and it's got to equal 32. Step 3 is start solving. So we're going to say 10x, negative times a negative is a positive, 2 times 18 is 36, negative 2 times negative 2 times 5x is negative 10x. I'm going to combine like terms. 10x minus 10x will cancel completely, so I don't need to write 0x. And we're left with the statement that 36 equals 32, which is a false statement. So that means that we have a no solution.